Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our studies on confidence intervals for small samples when our n is less than 30 and our sigma square is unknown. In our previous video, we learned confidence interval for large sample when our n is greater than 30 and then our population standard deviation is known. In this case, the distribution follows what? A normal distribution. But what about a case when our n is less than 30 and our population standard deviation is unknown? This is confidence interval for small sample. So we have some assumption that undergoes for us to accept that this confidence interval is for small sample. First is when the sample is a random sample. Second one, when the population standard deviation is unknown. When the population standard deviation is unknown, we use what we call the sample standard deviation, right? And then when our n is less than 30. So once this assumption is being achieved, then we are convinced that we are constructing confidence interval for small sample, right? And then the distribution that this confidence interval follows is what? T distribution with n minus 1 degrees of freedom. So it does not follow what? A normal distribution. Just put it at the back of your mind that this follows what? A T distribution. So let's go to our slide and see how the graph for T distribution. So this is a typical graph for T distribution. We have about 3 different colors here in this diagram. We have light blue, deep green, and then deep blue and what? Black, right? So for these 2 different colors, you could see that the first when you come inside the diagram, the first curve that you will see here, right, is having a degrees of freedom of what? 5. And the second curve is also having a T distribution having a degrees of freedom of what? 20, right? And then the next one is following what? Is Z, which is following what? A normal distribution. So they is just telling us that our n is for T distribution, our n is less than 30. But when our n continue to increase, and our n is equal to 30, then it's approximately what? Equal to what? Normal distribution, right? So you could see that there is some small similarity between the T distribution and the normal distribution. But there is a small explanation that I can give you on the graph for a normal distribution. What I want you to note down is that for normal distribution, we learned in our previous video that our n must be greater than 30. And then we just learned that our T distribution, our n must be less than 30. Sorry, our n must be greater or equal to 30. Our n must be less than what? 30. So if our n is less than 30, it will be within this range. It will be low. Our graph for the T distribution, the peak will always be below what? The normal distribution, as you can see it at the black here. But we are trying to say that when our n continue to increase, right? Let's say as n increase from 5 to 20, you will see that the peak continue to increase. But when it increase in such a way that our n is equal to 30, it's rather what follows what? A normal distribution, but not a T distribution. You get it? So always for T distribution, our n is less than what? 30, right? So let's go to how we can construct our confidence interval. So as you can see here, this is the formula for constructing confidence interval for the mean when our sigma, population standard deviation, is unknown and our n is less than 30. So here we have So for here we have our x bar minus T subscript alpha minus 2 comma n minus 1, right, times our x divided by square root of n. So you see the x, as you can see here, is just the sample mean, right? The x, as you can see here, is it's just the sample standard deviation. It's just the sample. Since we said the population standard deviation is unknown, we have to use the sample standard deviation less than our population mean, less than our sample mean, plus T subscript alpha divided by 2 n minus 1 times x divided by square root of what? N. So this is what we will have. This is how we can construct for our confidence what? Interval. So you see the right hand side is the same as the left hand side, but what differs is what? The operation signs. When you come to the right hand side, it will be plus. When you come to the left hand side, it's going to be what? Minus. So mind you, the n, you are not going to treat the n as we treated it as at the large sample. But for here, the degrees of freedom is n minus 1. So always the n that we have, we are going to subtract 1 from it. Right? So you understanding this, let's go and solve some examples. But before we solve the examples, I want to show you the statistical table for the t distribution. Right? So when you come here, we have what we call the confidence levels at the top. We have 80%, 90%, 95%, 98%, 99%, 99.8%, 99.991%. Right? So we have what we call the alpha level. Here we have a 2-tailed test, and then we have 1-tailed test. Right? So the 1-tailed test have its own alpha level, and the 2-tailed test have its own alpha level, and the 1-tailed test have its own alpha level. Right? So when we come here, this is what the 0.2, 0.1, 0.05, 0.02, 0.01, 0.002, 0.001, and then 0.1, 0.5, 0.025, 0.01, 0.005, 0.001, 0.0005. These are all called what? The alphas. Right? The alphas that you calculate. Right? And then what you can see here, the DF, right? Down here is called what? The degrees of freedom. Right? The degrees of freedom. So you are just going to compare the degrees of freedom to the alpha level to calculate for our t value, right, using the t table. Right? So please kindly understand this one for me, so that when we start solving the confidence interval examples, everything will be fine. So let's go to our first example. So our first example is saying 10 random selected people were asked how long they slept at night. The mean time was 7.1 hours and the standard deviation was 0.78 hours. Find the 95% confidence interval of the mean time. Right? So this question is being given to us. You see, we are not asked that we should use large sample or small sample, but the preambles here, right, the parameters here is going to help us to know that whether we are using a t distribution one or the normal distribution one too, I may calculate for it. Right? So here we see that our n is equal to what? Said 10 random people were asked, so our n here is 10. Right? And then we're given our mean, which is x bar, to be what? The mean time was 7.1 hours. So 7.1 hours. And then the standard deviation was given as 0.7. Our x here is 0.78. Right? Here, the population standard deviation was not given. So this is just giving us a clear picture that this one is confidence interval for small sample. Right? So we know that confidence interval for small sample is given by our x bar minus t subscript alpha divided by 2, n minus 1 times x divided by square root of n less than mu less than x bar plus t subscript alpha divided by 2, n minus 1 times x divided by square root of n. Right? So this is what we have for the confidence interval. But we are having t subscript alpha divided by 2, n minus 1. Here we have our x bar here to be 7.1. We have our x to be 0.75, and we have our n to be 10. Left with our t subscript alpha divided by 2, n minus 1. Right? That is what we are going to look for. Right? And then we know that our confidence interval, which is our CL, right, which CI is given as 95%. Right? So if our confidence interval is given as 95%, and we want the alpha, right, we know that our C is equal to 1 minus alpha. So here if we want our alpha, just make alpha the subject. So alpha will be equal to 1 minus what? C. Right? We are going to get 1 minus C. So our alpha here will be equal to 1 minus the confidence interval is 0.95, which will give us 0.95. Right? Our alpha is equal to 0.05. But here you could see clearly that our t value here, our alpha is divided by 2. So here I'm going to get t 0.05 5 divided by 2, comma 10 minus 1, of which you are going to get t 0.025, comma 9. So this is what we are going to use to go straight to the table to find our critical value for t subscript alpha divided by 2, comma n minus 1. So this is what we have, right? So when you go straight to the table, let me teach you how you are going to read it from the table. So when you come, this is the degrees of freedom, that's the TF. So you are going to locate 9 on the table. So this is 9, right? That's our degrees of freedom. And then when you come to this section, you see you are just going to look for 0.025, right? There is no 0.025 here, but there is 0.025 here. So you locate this 0.025. Right? Just trace the rows and the columns, right, to locate this one. So when you come here, you just trace it to this side and then trace this one to that side, right? So once you trace this one to that side, you are getting 2.262. So this is the critical value that we are going to have, right? So when we come here, you see we had 2.262. So right now we have our critical value, right? We have our critical value for this one. So we are just going to substitute. Our sample mean is 7.1. Coming. Our sample mean is 7.1, and our t subscript alpha divided by 2, comma n minus 1 is 2.262. Our x is 0.78, as you can see here, and our n is given as 10, square root of 10 here. So less than 7.1 plus 2.262 times 0.78 divided by square root of 10, right? So we are just going to add this one and subtract this one from that one. So when you do so, this is what you are going to have, and our confidence level, our confidence interval will be 6.54 less than 7.66, right? So therefore, one can be 95 confidence that the population mean is between 6.54 and 7.66, right? And then we have our second question to be: the data represent the sample of the number of home fire started by candles for the past several years, right? So the data are from the National Fire Protection Association. Find the 99% confidence interval for the mean number of home fires started by candles each year, right? So this is a data given to us: 5,460, 5,900, 6,090, 6,310, 7,160, 8,440, and then 9,930. So this is the data given to us. So this is just a sample, right? So you are going to find your sample mean, right? So the sample mean, as you already know, the sample mean is just our x bar, which is equal to 5460 plus, you are going to add this one and divide it by our n. So you are going to add this one, the whole of this one, plus 5900 plus 6090 plus 63110 plus 7160 plus 840 plus 9930 divided by the total. The total is 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8, you are going to get 7,041.4, right? And then we are also going to calculate for our sample standard deviation, right? So when you calculate for the sample standard deviation, you are going to get 1,610.3, right? Yes. So right now we have our sample mean, we have our standard deviation, right? So left with we calculating for our critical value, because we know our n2 to be 8, right? We know that our n here is what? 8, right? When you count this one, 1, 2, 3, 4, 5, 6, 7. Sorry, it's 7 right there. Sorry. So here you divide it by 7. I'm sorry. I'm going to divide it by 7, right? So our n is 7. So what is left for us to look for is our t subscript alpha divided by 2 n minus 1, and we know that our alpha is equal to c minus 1. Alpha here will be 0. Supposed to be alpha is equal to 1 minus c. Alpha here is equal to 1 minus 0.99, which will get alpha to be 0.01, right? So here alpha is 0.01. So you're just going to substitute alpha into this one. You get alpha 0.01 divided by 2, comma, our 7 minus 1, right? So once you divide this one by this, you are going to get t subscript 0.005, comma 6, right? So you are going straight to our degrees of freedom section and locate 6, and then go to the alpha level section and then locate 0.005, right? So let's go to the top there and do that. So right now our 6 is here, right? We are just going to locate for 0.005, right? So here is 0.0052. So 0.005, you are just going to locate it, trace it to this section, and trace this one to this section too. So this is what our critical value, which is 3.707, right? 3.707, right? So this is what we have, 3.707, right? Come in a minute. So since we have our mean, standard deviation, and then our n and the critical value, we can just substitute inside the formula. And don't forget that the formula is giving us the formula. Please, I'm coming. The formula is given by x minus t alpha minus 2 sigma. Here is x square root of n, right? Less than mu, less than x bar plus t alpha divided by 2. N minus 1 is here, comma, n minus 1, right, times x square root of n, right? This is what the formula, as you seen in the last example, in the previous example that we solved, right? So we are just going to substitute them inside. We know that our mu is 7041.4 minus 3.707 times our x, which is 1610.3 divided by square root of 7, less than that, and then just add that one too. Once we have this expression, we just subtract and multiply to get this one, and then hopefully our final answer will be given as 4,785.2 less than mu less than 9,297.6. So in conclusion, we are saying that one can be 99 confidence that the population mean number of home fires started by the canal each year is between 4,785.2 and 9,297.6 based on the sample of the home fires occurring over a period of 7 years. So this is the end of our video on confidence interval for small sample size when our n is less than 30 and population standard deviation is not known. So in our next video, we are going to treat confidence intervals and sample size for proportion. So kindly stay in touch. Bye.